after this week, you are going to want to decide, have I fallen far enough behind that I would like to focus on getting caught up and really understanding and practicing what we've already learned? Some people might be in this situation for all kinds of reasons. Okay, some people have little brothers and sisters that they need to look after. Some people have a job that they need to go to because, you know, they're working to help support their family during these times. Some people, you know, have just been struggling with mood issues around, you know, being quarantined and not seeing their friends and all of those sorts of things. So, you know, that can be for any number of reasons. But if you have been keeping up, you might want to decide, I would like to keep learning more physics. Okay, and just I want you to be aware that either option or a combination of both of those is totally fine. Okay, you can decide which way you want to go. If you've been keeping up, no problem, keep on going. Okay, the stuff we're going to do, it will do nothing but help you with your later grades. Okay, so grade 10, grade 11 sciences, everything we're going to do will be thoroughly applicable to that. But if you're like, you know what, I don't even know what the heck was happening in the naming and formulas section, and I just want to go back and do that. Or if you're really struggling with that algebra stuff from last week and you want to focus a little more time on that, you can do that. Like I said, doing a combination is also fine. If you're like, well, I want to keep going, but you know, I want to spend maybe a little more time on the algebra, that's also totally good. All right, so that's the student view. Well, that's not particularly awesome, is it? So when you go here, you should be able to click on that and you get a document that comes up. And I don't know if you've noticed this, but up here in the right-hand corner, can you see that little thing that keeps lighting up? Edit document. You can click on that, and probably the best way to work with this is to edit it in your desktop app. I'm not going to click on that right now because it's going to use too much computer power, but if you edit it in the desktop app, it will automatically save right back to here. So you don't have to download a copy. You don't have to do any of that stuff. You can edit it right from here in your desktop app, and it will save right to here. So if you haven't figured out how that works yet, you can just go and do that. And I just thought that would be a nice tip for people who hadn't done that yet. I have not yet had a chance to go and mark this. I will go and do that for you. Okay, but that's going to happen tomorrow. What I would like to do is I would like to, for number 8, you guys did only the first 4 steps of the 6-step method. And what we're going to do today is we're going to carry on and do steps 5 and 6. Okay, so for number 8, question A, we are asked how many coulombs, so I don't know how many coulombs, and what does coulombs measure? What is coulombs measuring? Oh, I could go over 1 or 2 practice questions from part 1. Yeah, for sure, I'll do that. What do coulombs measure? What quantity? Remember that a coulomb is a bucket of, what's it a bucket of?
Electrons.
Electrons, awesome, yes. Okay, so it's a bucket of electrons. And so electrons carry charge. So coulombs measures quantity of charge. Okay, so coulombs measures the amount of charge. And the symbol for charge is, what is the symbol for charge? What is the symbol for charge? Yeah, it's Q. So that is our thing that we want to find in this particular question. Okay. And we are told that we have 25 seconds. Well, I think we all know that 25 seconds is the measure of time. So we have 25 seconds. Is the abbreviation for time Capital T or lowercase t? Is the abbreviation for time capital T or lowercase t? Yeah, it's a lowercase t. Excellent. Okay, so we now have our Q, we have our T, and we are also told that the current is 5 amps. So we have 5.0 amps. And what's the symbol for current? What is the symbol for current? This one's always a little tricky. Yeah, it is an I. It's a capital I. It stands for intensity of current. Okay. Now, previously, in one of the previous questions, you had to write the formula for this. Okay. So the formula that relates these three variables is the current is equal to the quantity of charge over the amount of time. So we now need to solve this question for Q. We need to find Q. So we're going to isolate the variable Q. Okay, so this was step 1. Identify your unknown and your find quantities. Step 2 is to write down the formula. Step 3, we are going to isolate Q because that's what we're solving for. So we're going to isolate Q. Formula given find formula, isolate what you want to find. And so this is the algebra part. So this, we're going to do a little practice here with how we're going to figure out the how to solve for Q or isolate Q. And what that's going to look like is we need to make sure we need to get Q on the top. Hey, it is on the top. Yay! Okay, so that's actually done. We don't have to worry about that. The second thing we're going to do is we are going to we are going to declutter Q. Okay, I like to use that word declutter. What is cluttering up Q right now? What's cluttering up Q? Yeah, that T is cluttering up Q. Okay, so that's that we need to get rid of that T. So 2 ways of doing that. Okay, I'm going to show one of them in blue. So I have I equals Q over T, and I need to get rid of this T on the right hand side. So I'm going to multiply it so that it will cancel out. But if I multiply by T on one side, that would unbalance the equation, right? If I do something to one side and don't do it to the other, all of a sudden it's not equal anymore. So I also have to multiply the other side by T. Okay? And so now I have Q equals T times I, or Q equals I times T, whichever you want to write it. Okay? The second way you could do it, and I'll write this one in green, is you could do the same thing. You have I equals Q over T, and you can do the bring it on up, bring it on down. In this case, the T is on the bottom, so you are going to bring it on up. And so it will end up right here beside the I. And so what you will have then is you will have T times I equals Q. And this mathematical equation and this mathematical equation are the same. You can write the 2 variables right beside one another, either with the multiplication sign or without it. It really doesn't matter. Either way is fine. Okay? So now we've done step 3. We have isolated, we have found our Q. We've got it all by itself. And now step 4, we're going to plug our numbers and units in from our given and our given information. So we are going to, maybe I'll make that a little smaller so we can see it kind of all at once. So we're going to take our formula that we just had, and for step 4, we're going to plug in. Don't forget your units. Okay, so plugging in, we're going to have Q is equal to T times I. Okay, I've chosen to write it that way. I'm just writing it down here so that I can do this all in a line sort of here so you can see it. I'm going to substitute for T my 25 seconds. So I have 25 seconds. And my I is 5 amps. Okay, so this is going to be times 5.0 amps. And that is where I asked you to stop. Okay, so hopefully you made it to this point. If you didn't, I'm hoping that this has helped you a little bit to feel better about it. We're going to do the next one as well, and hopefully that'll help as well. Now, what we're going to do right now is I have seconds here. Does anyone remember a different way of writing amps? Is there some other way that we can write amps? Some other units that we can use to represent current? Can I break amps down into simpler units? Simpler units. An amp is, what is an amp? Yeah, an amp is a coulomb per second. An amp is a coulomb per second. Because remember, we are looking at current, I. And current is the amount of charge measured in coulombs that flows past a point in a given amount of time, which is the seconds, okay? And we sort of hide the units coulombs and seconds in this shorter form amp, but really an amp is a coulomb per second. So watch what happens if we rewrite then 25 seconds times 5.0. If I rewrite amps as coulombs per second, right? I've taken my amps, rewritten it as coulombs per second. Now, in the top part of this equation, I'm going to highlight the top part in yellow. Okay. Here's the top. That's all numerator stuff. If you wanted to, you could even put the 25 seconds like over 1 so you could see there's a denominator there, but you don't have to do that. Okay. But in the denominator, we now have seconds. Can anyone see what I can do with those units when I multiply the whole thing out? Anyone see anything that might happen that would be fun and special? Yeah, we can cancel those seconds. If you have a unit on the top and you have a unit on the bottom, you can cancel them out. So there go the seconds, bye-bye. Okay, right, because I got it on the top and the bottom. If I have 3 over 3 or 3 divided by 3, I would just end up with the 3's canceling. Similarly, if I have seconds on the top and seconds on the bottom, they will cancel out. So what I will have then is I will have 25 times 5. That's my numerical portion. 25 times 5 is 125. And the only unit I'm left with is the coulomb. And guess what? I was trying to find Q, which is the amount of charge, the quantity of charge. And what is charge measured in? It is measured in coulombs. The more you practice working with these units, and the more you practice thinking about an ampere as a coulomb per second, and knowing that you can put that into your equations and the more you practice with it, the better you will get and the more strong you will be going into, say, of course, like Science 10 or Physics 11, okay? Mainly Physics 11. I think in Science 10, it's still pretty straightforward. But yeah, so that is how you would do it. Is there anything that I have forgotten to do? So I did step 4, I plugged it in, I chugged it through. That was step 5. Step 5 was to chug my numbers through. What did I forget to do? I haven't completely finished this question yet. I forgot to box my final answer. Yes, I did. Okay. So I should box my final answer. Now I've boxed all kinds of things because I got excited about it, but you wouldn't be doing that. You wouldn't be like, oh, look, an ampere is a coulomb per second. I'm going to put a box around it so I can get excited about it. You're not going to do that. So you'll just have that one box and it will make it really easy for anyone who's marking it to see your answer. Okay. Shall we do the second one? And I've got another copy of this so I don't have to like erase. Okay, so here we go. There we go. Okay, not so big there. There. Okay, so this is 8B. And we are going to look for our step number 1. Write our given information and write out what we want to find. So we are given anything with a number. We have 6.5 coulombs. What is coulombs measuring? Coulombs is a measure of what? Coulombs is a measure of charge. It's how many buckets of electrons. Coulombs is a measure of charge. It's how many buckets of electrons. Okay. The next number that we are given, oh, and that was charge. What's the symbol for charge? What is the symbol for charge? Yes, the symbol for charge is Q because it stands for quantity of charge. Okay. Our second given piece of information is 10 amps. And so that's 10.0, and the abbreviation for amp is it a lowercase a or a capital A? Is the abbreviation for amp a lowercase a or a capital A? Yeah, it's a capital A. Okay, there we go. So we have 10 amps. And what does amps measure? Oh, I guess it says it measures current. What's the symbol for current? What is the symbol for current? Yes, it is I. So I, current is 10 amps. I standing for intensity of current. So that's what we're given. What do we want to find? We want to find, well, you look for the question words, how much? How much time? Okay, so time. And what do we measure time in when we're dealing with these kinds of equations? Seconds, yes. So we don't know how many seconds it is. Okay, so we're going to take that. And step number 2, we're going to write our formula. All right, hopefully at this point you're remembering that it is I equals Q over T. Okay, too bad it wasn't like Q equals I over T, because then it would spell quit, but it doesn't. Ict, iquit, I quit. Oh, ho, ho, ho. I quit. Look, there you can remember, except for this little, that's a T. That would be the T. It's that I down there that might mess you up. But anyway, that might help you remember it if you're into memorizing such things. But you can always just look up the formula, so that's not a big deal either. The third thing we're going to do, so that was our formula. What's the third thing we do? We isolate T. Okay, yeah, so we're going to isolate the thing we want to find. We're going to isolate T. Do you guys have a preference for which method to use? Like the bring it on up, bring it on down, or the cancel method? Anyone got a preference they'd like me to show? Nobody? Okay, I'll do it both ways then. Whatever. It's good practice to do it both ways. Okay, so if we're isolating T, remember that means that T needs to be on the top, and T also must be by itself, decluttered, okay? So is T on the top? Oh, no, too bad it isn't. So this time, first of all, I'm going to do it first by bringing it on up. I don't want it on the bottom, so I'm going to bring it on up to the other side. There was a song back in the 80s, and it went like, break on through to the other side, break on through to the other side. Anyway, bring it on up to the other side, bring it on up to the other side, or bring it on down. I don't know. Anyway, you can just ignore my singing. I'm sorry for that. Okay, so we brought it on up. It's going to go right here, and that means that our formula then is going to become T times I equals Q. Okay, and that's great. So we now have T on top, but it's not by itself. We need to declutter it. What's cluttering up the T? What is cluttering up the T? In this formula right here, what's cluttering up the T? The I, yeah. So we want to get rid of that I. And it's on the top, so I'm going to bring it on down to the other side. Bring it on down to the other side. Bring it on down to the other side. Oh, sorry. I know nobody wants to listen to that, but you have to because you're trapped here with me. Okay. So now I have a lovely formula where T is all by itself. Okay. If you prefer the other method of solving for T, I'll just do that over here, maybe in blue. I have I is equal to Q over T, and I need to get T on the top. So I'm going to multiply by T, which is going to put T on the top. It'll cancel out over here. And then I'm going to divide both sides by I to declutter it of the I, sort of doing it all in one line here. Okay, and that leaves me with T is equal to Q over I. T is equal to Q over I. Doesn't matter which way you do it, you now have this lovely formula. T, time is equal to charge over the current. So let's take a look at using this formula, and we're going to plug some stuff into it. So this is step number 4. We're going to plug in our numbers from here, here, and here. Gosh, that looks terrible. I'm just going to get rid of that. Okay. Okay, so T is equal to Q over I, our quantity of charge, 6.5 coulombs, 6.5 coulombs, divided by I, which is 10 amps. So we have 10.0 amps. And this is where I wanted you to finish up till last day. Okay, myself some more room here. But tell me, what could I write instead of amps? I could write coulombs per second. Absolutely, I could do that. That's fantastic, okay? So I'm going to do that. I'm going to, instead of writing that, I'm going to have 6.5 coulombs divided by 10.0 coulombs per second. Okay. Now, does anyone see what I could do with my units here? This one's trickier. This one gets a little bit, so if you don't quite get this, it's okay. Just go with the flow. Be okay with a little bit of uncertainty. Are there any units that I can do anything with there in this doodad here? I can cancel the C. There is a C in the numerator and there is a C in the denominator. And I'll let you know right now, most people do something a little wrong here and then they forget there's actually a 1 here. So this is still 1 over seconds. Okay. So what I have is I now have 6.5 coulombs over 10.0, and then I have 1 over seconds. Well, 1 over seconds is a really ugly unit, yeah? But if I was to have 1 over 1/3, what would that equal? What is 1 over 1/3? One-ninth? That's a great guess. If I have 1 over 3 just by itself, that's the reciprocal of 3, yes? And how do I take the reciprocal of something? I take 1 over x is the reciprocal of x. Okay, so if 1/3 is the reciprocal of 3, then 3 must be the reciprocal of 1/3. Anytime you put 1 over top of anything else, you can rewrite it as its reciprocal. Okay, that might be a little fancy math. You may not have done that for a while. Do you guys do that in math? Do you learn that in math? Do you do much in the way of reciprocals in math? Hello? Anybody? Not yet, kinda. Okay, so if you're not getting this, it's totally okay. Don't worry about it. If you're just like Miss Spence, you're just crazy. This is not making me happy, okay? Oops, why did I have a coulomb up here? That coulomb got canceled. At any rate, what I'm gonna end up with is I'm gonna end up with 6.5 divided by 10, which is 0.65. And my unit is going to be seconds because 1 over seconds is just a second. Okay, and I'm going to have to go talk to those math teachers and ask them what the heck they're doing, because by the end of grade 9, you should have done this. Maybe I should go write an angry letter to the ministry saying, what are you doing with our curriculum? Anyway, not your fault. Ministry's fault, not the math teacher's fault either. Anyway, okay. So if you're like, okay, I'm not really getting it, it's okay. This one is really tricky, okay? Doing this particular thing where you end up with this like little 1 over unit is very tricky. I would like it if you could, like the last one we had, where'd it go? Come on, there we are. This one here, I think this one was much more manageable, where we had the seconds and then we had coulombs over seconds and they canceled out. Oh, I had a thought. Numerous people have expressed to me that they're having trouble with motivation. I would say, if you're having trouble with motivation, if it's related to mood and whatever, you might want to talk to a counselor. That's great. It doesn't have to be a school counselor. You can talk to anybody. But if it's just like, you know what, I just really prefer, if your lack of motivation is because I prefer playing video games or I prefer spending time on social media, you might want to check out this thing. It's called dopamine detox. You can go look it up on YouTube. I thought I would do it myself, and then I realized I work like 10-hour days, and so I don't really need any motivation to work more. So dopamine detox, you can go on YouTube. I think the guy who does the videos, his name is Andrew Kirby. And just kind of check it out. See what you think about it. See if you could do a dopamine detox for yourself. What it involves is just getting rid of all the things that fire those little, you know, what do you call it? When you play a video game, or when you watch TV, or when you do something fun, or when you eat some junk food, it makes the dopamine in your brain. It releases the neurotransmitter dopamine in your brain. It makes you feel good, okay? And you don't want to do other things because you don't get that same dopamine hit. So it's like you're addicted to all these different activities. But if you do this sort of dopamine detox and rewire your brain a little bit to get that same hit of dopamine from doing something constructive, then you're going to be more productive. Anyway, I don't know. Worth checking out. Okay, so give me half an hour to put that up. And that's it for this week. Thank you guys very, very much.